In this video, I'm going to show you how to use the law of sines to calculate an unknown side of a triangle. So here we've got a triangle labeled with a particular naming convention. This convention works like this. The vertices of the triangle are labeled with capital letters. So A here for this corner, B here for that corner, and C there for that corner, all capital letters. And then the sides are lowercase a, b, and c, with the letter of the side matching the letter of the angle across from it. So A matches with A, B matches with B, C matches with C. Now, for any triangle labeled in this fashion, we have a true statement called the law of sines, which relates the sines of the angles and the sides all together. And it goes like this. The length of side A divided by sine of angle A is the same as the length of side B divided by sine of the angle B, and that is also the same as the length of side C divided by sine of the angle C. For corresponding sides and angles, that's always going to be the same ratio in any triangle. And yeah, that works for every triangle. Law of sines always holds. Now let's see the law of sines in action. So let's use the law of sines to find the value of A in this triangle, the side A. So here's our law of sines, and here we've got our triangle ABC labeled with angles in capital letters and sides in lowercase letters. We want to find that value for A. So why don't we turn to our law of sines to do this? So we'll look at this A over sine A part. That's relevant because we want to find out what A is. So why don't we start off with that? We'll start off with this side, the equation A over sine A. And we want to set up an equation using some other known quantities from the triangle. So what else is known in the triangle? Well, we don't know anything about angle C or side C, but hey, look, angle B, we have an angle measured there, and we also have a side measured there. So why don't we take that B over sine B, and we'll use that at the right hand side in our equation, B over sine B. And now let's just go ahead and put in our information from the triangle. And we should construct an equation where A is the only unknown. So we'll have A over sine of A, and we know that angle A is 70 degrees, so A over sine of 70 degrees is equal to B over sine B. Well, B is just 2, so 2 over sine of angle B. Angle B is 10, so there we go. Now we've got an equation with just a single unknown A, and we can solve. So to solve for A, why don't we just multiply both sides by sine of 70 degrees, and we'll get A is equal to 2 over sine of 10 degrees, that times sine 70 degrees. And all we have to do is put this in our calculator, and then we'll get a nice approximation for A. A is approximately 10.82. So there we go. There is our measure for the value of lowercase a, this side here. Here's another problem. So the triangle ABC has measure of angle A equals 32 degrees, measure of angle B equals 104 degrees, and side A equals 5. We want to find the length of side C. We've got our law of sines, but we don't have a drawing of the triangle, so why don't we create one? So we'll draw a triangle ABC with measure of angle A equals 32 degrees, so make a nice acute angle here for angle A. So how about something like this, roughly? Yeah, so this can be our angle A here. So let's label that angle A and label that with 32 degrees. Okay, and then angle B is 104 degrees, so that needs to be a slightly obtuse angle. Why don't we draw that on top here? We'll make this top angle slightly obtuse, so maybe something like this. Get down and line it up roughly with where it would intersect the base, and then continue that base a little bit. So then here is our angle B with 104 degrees, and then we lastly have angle C, and while we're at it, why don't we just figure out what measure of angle C is? That's not given, but since the triangle sums to 180 degrees, measure of angle C is just going to be equal to 180 degrees minus the other two angle measures. So minus 32 degrees and minus 104 degrees, and the result of that is just 44 degrees. So that's the measure of angle C. C is just 44 degrees. Okay, so now we've got our triangle. Let's also label the sides too. So we've got side A across from angle A. Side A, we're told that's equal to 5. And then side B is across from angle B. We're not told what that is. And then side C is across from angle C, and we're not told what that is either. That's actually the thing that we want to find. What is the length of side C? Okay, so now let's set up our law of sines for this triangle. So we know that we're going to be using the C over sine C part because we want to solve for what is C, the side length C. So let's write C over sine of C. And that's going to be equal to, well, what should we use for the other part? We want to use something where we know the values of the other side and the other angle. So B, we know the value of angle B, but we don't know the value of side B. So that's not going to help us too much because we'll still have a missing variable in our equation. But hey, look, we know the measure of angle A and also the measure of side A. So why don't we choose A over sine A as the other part to the equation? A over sine A. Okay, great. So now we can fill in missing information. So C is unknown, but we know what angle C is. Angle C is 44 degrees. So C over sine of 44 degrees is equal to side A. Side A is just 5. So we have here 5 over sine of angle A. Angle A is just 32 degrees. So 5 over sine of 32 degrees. And now we can go ahead and solve this equation for C by just multiplying both sides by that denominator, sine 44 degrees. And we get C is equal to 5 over sine of 32 degrees times sine of 44 degrees. And we just stick that in our calculator and we solve for what that is. The result, C is roughly, approximately, just 6.55. So there we go. That is the length of side C. In these examples, we focused on solving for the missing side lengths of triangles. In the future, though, we'll also see how to use the law of sines to solve for missing angle measures of triangles.